7.3 Modeling using variation. Radiation machines used to treat tumors produce an intensity of radiation that varies inversely as the square of the distance from the machine. At 3 meters, the radiation intensity is 62.5 millointegens per hour. What is the intensity at a distance of 1.6 meters? Okay, so we have an intensity of radiation, so I guess I could use I. Just I'll use I for intensity. Yeah, which is equal to, varies inversely. Now it says varies, so we know we're already equal to k. Then it says inversely, which we know that means division, as the square of the distance. Square of the distance. So distance squared. Okay, so I got it. You can move some of the, you don't have to use the variables I use if you don't want to. Now, they say at 3 meters, so let's see, at 3 meters, so we have k, and then they have distance, but now they have 3 squared. The radiation intensity is 62, so 62.5. Okay, excellent. Okay, so let's solve this. So 62.5 is equal to k over 9. We undo the division of k by 9 by multiplying by 9. Whatever I do to one side, I do to the other. Those cancel out, leaving me k is equal to 562.5. Then we rewrite the original equation of I is equal to k, but now k we know is equal to 562.5 over distance squared. Now they say, what's the intensity whenever you have distance squared, where distance is instead 1.6 meters. So now we square the 1.6. Now I is equal to, we say 562.5 over 1.6 squared, which is 62.56. And we say I is equal to 562.5 divided by 2.56, and that is equal to 219.7265625, yada, yada, yada. Kind of keeps going. Okay, now, we probably want to round this to the nearest unit of intensity. So we would say this is approximately, we look at the 9 to the right of it as a 7. 7 is 5 or greater, so we round up. 9 goes up by 1, turning it into a 10. We carry over the 1, and we end up with 2, 2, 0. So it's approximately 220. Let's try the next one. One's intelligence quotient, or IQ, varies directly as a person's mental age and inversely as the person's chronological age. A person with a mental age of 18 and a chronological age of 35 has an IQ of 108. What is the chronological age of a person with a mental age of 20 and an IQ of 140? Okay, so intelligence varies. So it's something, I varies. So we are up to I is equal to k. Then they say directly, okay, cool, now we're multiplying. A person's mental age. Okay, so they have mental age and chronological age, so I'm just going to put an M here. And then they say inversely. Oh, that means division. And they say chronological age. So chronological age goes down here. I'm just going to use a C. Okay, so we have a person with a mental age of 18. So I'm going to put an 18 right there. They say they have a chronological age of 35. Put that down there. And they say they have an IQ of 108. Okay, so how do we solve this? Well, first I undo the division of k by 35 by multiplying by 35. Whatever I do to one side, I do to the other. Okay, you can also multiply both sides by the reciprocal of 18 over 35, which is 35 over 18. But I'm breaking it in, hopefully what makes this seem a little simpler. Possibly, right? Okay, so that gives me 3,780 is equal to 18k. And then I divide by 18, I divide by 18, cancel, cancel. And that gives me k is equal to 310. Okay, so we rewrite the original equation, but now where we have the k, now I'm going to put 310. So it's 310m over c. Okay, now they say, what is the chronological age of a person with a mental age of 20? Okay, so now we have a mental age of 20. Mental age of 20. They want to know the chronological age, which means that's the one we don't know, but we do know that the IQ is 140. Okay, so I'm going to multiply both sides by C, which gives me 140C. is equal to, and then 310 times 20, we would say that is a 6200, 6,200. Then we undo the multiplication of C by 140 by dividing by 140, and whatever I do to one side, I do to the other, and that gives me C is equal to 30. So their chronological age is 30. Okay, so we say kinetic energy varies jointly as the mass and the square of the velocity. A mass of 12 grams and velocity of 3 centimeters per second has a kinetic energy of 54 ergs. Find the kinetic energy for a mass of 4 grams and a velocity of 5 centimeters per second. Okay, so kinetic energy, I think I'll just, you can put K, E, or you could just put, I'm just going to put E. Varies, so we're all the way up to equals K. Jointly, they're going to list some things out here as mass, cool, M, and square of velocity, velocity squared. Okay, so we have a mass of 12 grams, velocity of 3 centimeters per second, and it gave me an energy of 54 ergs. 54 ergs. Okay, cool. So we have 54 ergs. Okay, order of operation, we have to do the square first. So we say 12 times 3 squared, which is 9. Then we'd say 9 times 12, which is 108. And how do we solve for 108? How do we solve for k? We undo the multiplication of k by 108 by dividing by 108, 108. And whatever we do to one side, we do to the other. Those cancel out. That gives me 0.5 is equal to k. So I go back and I rewrite the original equation, but now I have 0.5, and that's times m, and that's times v squared. You don't really need all these dots. I'm just trying to emphasize the operations. Okay, now at this point they say, find the kinetic energy for a mass of 4 grams and a velocity of 5 centimeters per second. So we say E is equal to 0.5 times m, which is the mass, which is 4, times 5, which is the speed. That's E is equal to 0.5. Order of operations, as I say, 5 squared is 25. And then finally, we can multiply everything through. 0.5 times 4 is 2. 2 times 25 is 50. So we get 50.